Arunkumar and this is Madhan, Mohana, Sundaram. We are here to demonstrate our project on balancing board using LPC 1768. Madhan will be telling about the algorithm behind the working of the board and other stuff.
Okay, hi guys. So the board primarily consists of the LPC 1768 board, that is the embed board, and it also has an onboard accelerometer that gives the orientation and the acceleration along the directions of the robot to the main board. And it also has a driver IC, that is a H-bridge, 1 ampere H-bridge driver that is used for powering the dual motors that control the robot. And the rest of the connections are just basically wire-to-wire connections. And the algorithm consists of getting the values from the accelerometer using I2C protocol, that is the inter-integrated circuit protocol. And after receiving the accelerometer values, the values are sent into a Kalman filter that filters out the noise in the accelerometer and gyroscope values, because accelerometer values have a lot amount of noise and gyrometer values have a lot of drift on them. So the Kalman filter gets both of them as inputs and outputs a stable orientation value, and that value is used by the embed controller to power up the motors in the respective directions. Now Arunkumar will be explaining the rest of the code.
Yeah. Well, whenever the microcontroller senses any change in your position, you should operate. That's the basic principle. For example, if I'm trying to tilt the board over this side, it should sense that the accelerometer should sense that the direction is changing by in terms of accelerometer values. It's like plus 1G or minus 1G, followed by my gyroscope values, which is in 0 to 360 range. From those values, we are getting into the microcontroller. We are computing our own angle using Kalman filter. After that, according to the values of accelerometer and the gyroscope, we are switching between forward and reverse directions so as to balance the board. So in this board, we are using PWM pins 22 and 23, and we are using it to be mapped to a H-bridge driver. The drivers are like 4 input, 4 output, and the center ground pin. And also it has an optocoupler inside it so as to guard against any errors or other margins. And then here's our hardware setup, and here we are giving 5 volt supply to the microcontroller using a separate DC supply source and a 4.4 volt, which is the rated voltage of a motor, and at 1.37 ampere. That's because a motor rating is 1.2 ampere and we are supplying below load conditions. So for example, now initially it's tilted and I'm now setting the values, so the board is automatically adjusting itself. So what happens, I'll explain now what happens. So when I'm giving a push like this, the accelerometer values and gyroscope values are changing, and when they are changing, the microcontroller senses it up and computes its own angle using the Kalman filter, and then according to the angle obtained, it tries to change the drive bits, which are used to drive the motor. The drive bits are sent to the H-bridge driver, and then the motor is driven from the H-bridge. So for example, if it's in the reverse direction, it's the same thing. So whenever the disturbance is given, the system tries to obtain itself to stability with a slight time deterioration. So that's it about the board, and we would like to thank our professor Praveen Madhuri for providing us with the lab facilities, and also the TAs who helped us in during our project work cycle. Thank you.
Thank you.